Okay, very good morning, children. In today's class, we will be having a glance on the chemical bonding, whatever the base in the video 1, video 2, video 3 I have sent to that important areas where we want to stress that we will be having a discussion in this. Generally, we all know that ionization energy is a which type of process? We have two types of processes, exothermic and endothermic. In that, ionization energy is what is the definition of ionization energy? The minimum amount of energy required to remove an electron from its outermost gaseous atom. So minimum energy we are saying means we are giving energy to the system. Then it is which type of thing it is? Endothermic process. Is it or not? It is an endothermic process. Okay, ionization energy is an endothermic process. Next, electron affinity is there. What is meant by electron affinity? So the maximum amount of energy that is released when an electron is added to a neutral atom. Is it or not? Means what? It is release of energy. Release of energy is nothing but which process? Exothermic process. So electron affinity is an exothermic process. Okay. Next, what we have? Lattice energy. So lattice energy is now depending upon what? Ion. Lattice energy. The more the lattice energy, the more probability will be the ionic bond. Is it or not? So lattice energy means what? It is also the amount of energy released when a crystal lattice is formed. When a crystal lattice is formed, that amount of energy is being released. So we call it as exothermic again. So lattice energy lattice energy is an exothermic process. And already I said you the ionic bond depends upon the electronegativity differences. The more the electronegativity differences, the stronger will be the bond. Is it or not? The more the electronegativity different. Then how we can know the electronegativity for which element, how much is? So I am going to give you now the standard electronegativities of some elements. Okay, electronegativity of some elements we will see. Electronegativity of oxygen, fluorine, chlorine, nitrogen and hydrogen. Okay, electronegativity of oxygen is 3.5 and fluorine is 4 and hydrogen is 2.1 and chlorine it is 3 and nitrogen is also 3. Both are having the same. Okay, so these are the standard. Suppose if a bond is formed with fluorine and hydrogen, the electronegativity difference is how much? 4 minus 2.1. Bond between hydrogen and fluorine, if you take, it is 4 minus 2.1. Means how much it is? 1.9. Bond between hydrogen and oxygen, how much it is? 3.5 minus 2.1. Okay, now bond between hydrogen and fluorine, 3 minus 2.1. So now you can calculate, it is 1.4 and it is how much? 1.1. So the highest bonding will be between what? 1.9. Highest. H of bond will be having the highest. Like that we can see. So more the differences, more Is it or not? The strength of the bond will be more. So you please make a note of all these points. Okay, now we will be having already ionic bond means what we have said, it is due to the transfer of the electrons. Okay, now we will be seeing another type of bond, that is covalent bond. So before we enter into the covalent bond, the meaning is what? The definition is what? It is due to the sharing of the electrons. Sharing may be done between the same type of elements or between the different types of elements. And there are so many chances. What one can give some type of contribution and other can give other type of contribution. Example, suppose two friends are there. They want to purchase a chocolate which is cost of 10 rupees. But none of them are having 10 rupees. One is having 5 rupees and another one is having 5 rupees. Here what, if they both contribute, they will get the equal. Is it or not? Then they will get the chocolate. There is another set of friends who are having difference in their contribution. One is having 8 rupees and another one is having 2 rupees. Even if these two also get, they can get the chocolate. But now here what it depends upon the 8 rupees nature. If he feels that he has to give more, he has to get more portion, he will take more portion. No, let it be, I will share equally means he can share. It all depends upon the nature of the particular person. In the same way here also, covalent bonding. We have two types of bonds again. Polar covalent bond and non-polar covalent bond. Okay, polar covalent bond and non-polar covalent bond. See, these polar and non-polar can be defined on 4 types of bases. Okay, these can be defined. How they can be defined means on 4 bases we can define. One is mode of their formation, on what basis they are forming. Means same atoms are on different atoms of elements. On that we can define. And another one is between the charge separation. Due to polarization concept, they may get some charge separation, and the types of atoms involved. And based upon the electronegativity also you can define these can be defined. Okay, polar covalent bond and non-polar covalent bond definitions you can define by these things. Okay, by mode of formation, charge separation, types of atoms involved, and also on electronegativity. Okay, based upon these things we can define the polar bonds. Now I will be explaining you in detail about one by one concepts. Okay, what is a polar covalent bond? First, on mode of formation we will see. Polar covalent bond is a bond formed by unequal sharing of electrons between the bonded atoms. Okay, so this is one type of bonding. See, polar covalent bond is a bond formed by the unequal sharing of electrons between the bonded atoms. Okay, and there is another one. What is that? Non-polar covalent bond. So it is by the equal sharing of electrons between the bonded atoms. Non-polar covalent bond is a bond formed by equal sharing of electrons between the bonded atoms. Okay, so this is the way we have. Next one, what? Charge separations. Based upon the charge separation, how this? Okay, that we will see. Polar covalent bond results in the formation of opposite partial charges on the bonded atoms, which is called dipole. Okay, see, polar covalent bond results in the formation of opposite partial charges. Means generally I said in the starting of video 2, there is no such cent% ionic bond. There will be partial covalent bonding. That is partially charges on the bonded atoms, which is called as dipole. And then you will be getting dipole moment. So what is dipole means? Partial charges on the bonded atoms, opposite. Okay. So polar covalent bond results in the formation of opposite partial charges on the bonded atoms. Okay. Next, non-polar covalent bond does not result in charge. Why it does not result in charge means they are of the same atoms. No, see, both are having the same charge. How the things will be there? So there is no question of no result in charge. Does not result in charge separation. Does not result in charge separation. Separation between bonded atoms. See, there is no question of charge separation in case of non-polar bonds. Is it clear? There is no question of charge separation between non-polar covalent bonds. There will be charge separation only between polar covalent bonds only. Dipole moment exists only for polar covalent bonds. Why? Dipole means what? Polar covalent bond results in the formation of opposite partial charges on the bottom atom, on the bonded atoms, which is called as dipole. That is the case. Okay. Next, polar covalent bond is formed. Types of atoms involved. So polar covalent bond is formed between the atoms of different elements. That's why they have different charges. Okay. Whereas the non-polar formed between the atoms of same elements. Okay, please note down this. The remaining we will have now discussion. So now the definition based upon the atoms we will write. So what we are saying, based upon the atoms, polar covalent bond is formed between the atoms of different elements, and non-polar covalent bond is formed between the atoms of same elements. This is the case. Next, based upon the difference in their electronegativities. The two atoms in a covalent bond have the same electronegativity. No dipole is formed. If no dipole is formed, what we can say? It is polar or non-polar? Non-polar. And the bond is classified as non-polar bond. See, if they have the same electronegativity, means no dipole. This you can expect in the form of bit. When there will be no dipole means when they have the same electronegativity also, they don't have the dipole. If there is no dipole means there is no question of polar covalent bonding. It will be of only non-polar. Okay. When the two atoms in a covalent bond have the same electronegativity, okay, then no dipole is formed. Same electronegativity is possible. Okay. Next, when the electronegativity of the atoms differ, a dipole may form. A dipole may form, and the bond is classified as a polar bond. the more polar bond. Okay. So when the electronegativity of the atoms differ, a dipole may form, and the bond is classified as a polar bond. Greater the difference, the more polar bond. Okay. So in the previous class I said, if the electronegativity difference is at least 1.9, then only ionic bond is formed. If it is less than 1.9, then it forms covalent bond. If the electronegativity difference between the atoms is less than 1.9 or 1.7, in some books it is taken as 1.9 and in some books it is as 1.7. Whatever it may be, depending upon the situation you can. If it is less than, if the word used is less than 1.7 or 1.9, then it forms covalent bond. Okay? You can make a note of these points also. So, if the electronegativity difference between the atoms is less than 1.7 or 1.9, okay, then the bond is a predominant covalent bond. That you should make it very clear. If electronegativity difference between two atoms is less than 1.7. In some books it is written 1.9, no problem. 1.7. The bond is predominantly covalent. Okay, it is covalent bonding. Next, generally you can see sodium and chlorine. There is a large difference in their middle. Sodium is 11 and chlorine is 17. Is it or not? Okay. So the greater the distance between the atoms in a periodic table, the greater will be the difference in their electronegativities, and hence greater will be the polarity of bond between them. Okay. So the greater the distance between the atoms in a periodic table, the greater the difference in their electronegativity. And hence greater the polarity, and hence greater the polarity of bond between them. Okay. So this is the case we have. You can note down. So in this video I have given a clarity regarding polar bond and non-polar bond. Okay. Next we will be discussing about the polarization. Before we enter into the polarization, we want to have a concept regarding covalency also. Okay, now we will be discussing about the valency and covalency concept. So already we had a clear-cut discussion. The modern concept believes that outermost shell should contain 8 electrons. Okay, that 8 electrons is nothing but octet configuration. Containing 8 electrons is the responsible will leads to the chemical bonding. So what I can say, the electrons that are present in the outermost shell are known as valency electrons. But what is covalency? What is covalency? Okay, valency means that we have, see, the modern concept believes that outermost shell electrons of an atom are responsible for chemical bonding. So these electrons are known as valency electrons. Okay, then what is covalency? Then what is the concept of covalency? That is in our mind. So let me give a clear picture about first what is valency and what is covalency. Let us consider chlorine. Chlorine atomic number is 17. Okay, so 17 means electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. Okay, that is nothing but 2, 8, 7. So the last shell is this only, no? So what we will write in the ground stage? Let us take it as ground state. In ground state, what will happen? This is the 3s2, 3p5, and d orbital will be 1, 2, 3, 4, 5. 3d 0. Why means there is no d orbital, but let us consider it as 0. Okay. Now what will happen? You see, 5 electrons first. Is it or not? So the covalency is how much in this case? The covalency is 1. Why? Unpaired electron is considered as the covalency. Now you take first excited state. So in the first excited state, let us consider this is the 3s2. One, 2, 3, and 4. Now the d orbital will occupy 1, 2, 3, 4, 5. Is occupied with one more electron. This shared electron will jump into this. So here what is happening, you see. Have you understood? So this is the, now the covalency is how much for this case? Covalency is 2 here. 2 unpaired electrons. 2 or 3? 1, 2, 3. So 3 is the state we will see now. So in the second excited state, what will happen? This will be like this only, and now this pair broken. Again here 1, 2, 3, 4, 5. So this has to come that side, and already one is there. Now the covalency is how much? How many are untied? 1, 2, 3, 4, 5. Next, third excited state. All are completed, so this has to break now. One, two, three, four, five. 1, 2, 3. Now total, what is the covalency? Now you see 1, 2, 3, 4, 5, 6, 7. So chlorine is showing different types of valencies. It can form, it can share, or it can form bond which can donate 1 electron, which can donate 3 electrons, which can donate 5 electrons, and which can donate 7 electrons, or which can share 7, 5, 3, 1. So that is the covalency of electron. Have you understood now the concept of covalency? It is nothing but what we can say, the number of electrons contributed by the atom for the bonding purpose or for the sharing of their things with other atoms is called as covalency. Okay? And p block elements show maximum covalency. P block elements show maximum covalency. D block elements will show variable covalency. Okay? D block elements show variable valency. Variable covalency. Have you understood the difference between valency and covalency? Covalency is related to the covalent bonding only. Okay? So the definition is, it is defined as the number of electrons contributed by an atom of the element for sharing with other element, so as to achieve the nearest inert gas configuration. That is called as covalency. Okay, you try to understand this. I will give you the definition. I will write it on the board. See, first excited state. In ground state, the covalency is 1 only. So this is, okay, in ground state the covalency is 1 only. But in the first excited state of chlorine, the covalency is 3. And in the second excited state of chlorine, the covalency is 5. And in the third excited state, the covalency is 7. Okay? You can note down the definition of the covalency clearly. So, what is the definition of the covalency means? It is defined as the number of electrons contributed by an atom of the element for sharing with other atoms so as to achieve noble gas configuration. It can also be defined as the number of covalent bonds formed by the atom of the element with other atoms. And P block elements show maximum covalency, and d block elements will show variable covalency. Okay, I am writing here the definition. You can see clearly. Covalency is defined as the number of electrons contributed by an atom of the element for sharing with other atoms so as to achieve noble gas configuration. Okay, and what I am saying, it can also be defined as the number of covalent bonds formed by the atom of the element with other atoms. So this is the definition of covalency. Okay, covalency is this. Next, second period elements cannot have covalency more than 4. Okay, why? Means they don't have the d orbitals. No, d orbital starts with 3. Is it or not? So we have to write this point. Second period, most important for competitive exams. Second period elements cannot have covalency more than 4. Due to absence of vacant d orbitals. Okay, so maximum covalency of fluorine is 1 and oxygen is 3. That's why they can form that only maximum of HF, that's all, and it can form oxygen, CO, CO2 and H2, single bonds, double bonds only it can form, and the same double bonding. So maximum covalency is 3 for oxygen. So this is all about the valency and covalency things. And one more thing is pseudo inert gas configuration. What does it mean, pseudo inert gas configuration? What is meant by pseudo inert gas configuration? See, inert gas configuration means you know well. What is inert gas configuration? What is inert gas configuration? NS2 NP6. Then what is pseudo inert gas configuration? Simple logic I will say here. You see, in inert gas you will have S2 and P6 filled. In pseudo you will have D. That is the difference. S2, P6 and D10. That is called as pseudo inert gas configurations. Okay. So you can make a clear note of all these things. Next we will be having the discussion regarding the polarization concept. So pseudo inert gas configuration means S2, P6 and D tank.